Below Lake Oswego's tranquil waters, there's a problem.
A failure of this pipeline would be catastrophic.
The community's sewer system is undersized, corroding, and prone to collapse.
A crack can be discerned, very small circumferential crack, right approximately at the pipe joint.
But the city has a plan. Construction of a replacement begins in 2009. Still, it won't be easy to build a new system in this remarkable setting. Etched into Oregon's Willamette River Valley is a narrow lake, solitary and idyllic. The people who knew this place first called it Waluga, the sound of wild swans touching water. Early Europeans named it Sucker Lake for the abundance of fish it supplied. But in the first decades of the 20th century, after an iron ore industry rose and fell on its shores, locals recognized its potential as a storybook setting for life on the water. Residents committed themselves to enjoying it and protecting it. In the 1930s, while cities up and down the Willamette dumped their waste in the river, Lake Oswegans built one of Oregon's first sewage treatment plants. The infrastructure for water quality, though hidden from sight and easily taken for granted, was valued by locals, and still is.
My name is Jill Walker, and I live in Lake Oswego. I love Lake Oswego because it does things right. Not only is it a beautiful city, it takes care of the things we don't see in the city, like the sewer and the water. I always depend upon that.
But imagine if things were different, that you had to store and haul your own wastewater. On average, each resident produces 80 gallons of effluent a day to flush toilets and take showers, to do laundry and wash dishes. For a typical household, that's the equivalent of more than 40 garbage cans every week.
If you have problems with a sewer system, you've got serious problems.
Lake Oswego's sewer line was built in the 1960s when the city's population was under 10,000. Today, an additional 26,000 people live here, and many more are on the way. The old system is undersized, and during periods of large storms, it shows.
People notice it when we have the overflows. So they see untreated waste bubbling up out of the manholes. Those are considered illegal discharges to the waters of the state.
Engineer Joel Kamarick directs the city's Interceptor sewer project. The city had hoped to build upon the existing sewer, which runs along the lake bottom to the Tryon Creek treatment plant.
And so we had a team of divers enter the lake and do a visual inspection.
The whole downstrap has conspicuous corrosion. All remnants of coating and galvanizing are gone.
Even a moderate earthquake could cause collapse.
A failure of this pipeline would be catastrophic. We would have literally 3/4 of the community upstream of the pipe without any sewer service.
Engineers considered a new interceptor along the shoreline, but it required costly pumping stations and twice the length of pipe. Studies showed that a replacement system in the lake would be the least expensive, most reliable solution. At the shallow ends of the lake, the new interceptor and trunk lines will be held in place by 300 steel pile supports drilled into bedrock. Where the water deepens, a 42-inch diameter pipe will run through the lake more than 8 feet below its surface. Buoyant tubes will hold the pipe at just the right slope for a distance of nearly 2 miles. Over 400 wire cables will anchor it beneath deep sediment to bedrock. The system's corrosion-resistant technologies are expected to last a century or more.
It's an assembly of very well-tested components that have a long track record in much more demanding environments.
John Holland is the lead engineer for the Interceptor at Brown and Caldwell.
The key is that we control slope of the system so that the sewage will continue to flow downhill and operation and maintenance will be kept to a minimum.
The energy-saving design allows gravity rather than pumps to do the work.
I take the success of this project very personally. There's no room for any kind of unanticipated problem along the way.
which is why engineers recheck everything, even before construction.
500 tons of pressure right here. Just watch your fingers.
Today, after 6 years of engineering design and public review, the Interceptor team faces a high-stakes test.
We're here at Cascade Rigging to confirm the design of some of the critical hardware pieces that will be holding the pipe in place to make sure the system will perform.
We've got our own test bed here that'll pull up to 250,000 pounds. So we actually load the wire into the test bed, put it in place, we turn the machine on, the hydraulics then go to a pull point. And when it breaks, it's going to go off like a gun.
Okay, that's good.
A broken cable signals success. The hardware handles loads over 400% higher than extremes expected in the field.
The goal here for this project is no surprises.
Coming up, building barges on the lake as construction begins.